Without wasting time, we will continue from where we stopped in part 13. This is part 14. Question 11, question 19. The melting point of a substance is equivalent to its dash. Remember, pay attention. Give me your attention now. Run away from any distraction, okay? The melting point of a substance is equivalent to its dash. A, vapor pressure. B, solidification temperature. C, liquidification temperature. D, solidification pressures. The melting point of a substance is equivalent to its A, vapor pressure. This is where we stopped in part 13. Vapor pressure. B, solidification temperature. C, liquidification temperature. And D, solidification pressure. The answer to question 19 is B. The melting point of a substance is equivalent to its solidification temperature. The temperature in which the water vapor present in the air is just sufficient to saturate air is dash. Pay attention. I've often told you that as you are reading and noticing the topics that the questions are coming from, also know that you should also be reading your textbook. I've also done a video on 15 topics that JAMB questions will come out from this year, from the syllabus. Okay, so focus on those topics and read them up. Eat your textbook so well that no question will come to you as a surprise. The temperature at which the water vapor present in the air is just sufficient to saturate air is dash. A, boiling point. B, ice point. C, saturation point. D, dew point. What is the answer? The temperature at which the water vapor present in the air is just sufficient to saturate the air. Is it boiling point, ice point, saturation point, or dew point? The answer to question 20 is D, dew point. Dew point. Dew point. Remember in the previous video, part 13, we handled something about dew. Question 21. Heat transfer by convection in a liquid is due to the dash. Heat transfer by convection in a liquid is due to the dash. A, latent energy of vaporization of the liquid. B, increased vibration of the molecules of the liquid about their main position. C, just pay attention. C, variation of density of the liquid. D, expansion of liquid as it is heated. Let me give you a secret. Some of you don't know that JAMB will ask more of theory questions than even calculation when it comes to physics, when it comes to biology and chemistry. There is a lot of theoretical questions beyond calculation questions. Why? Because JAMB is CBT. JAMB is computer based. So they basically want to know whether you understand. They will say ask maybe 10-15 questions that are calculation based, but most other questions will not require calculation or calculator. Heat transfer by convection. You know we have 3 types of heat transfer. Tell me, mention them. Assignment number 1 in this video. Mention the 3 forms of heat transfer. Mention for me in the video, in the comment of this video. It's an assignment and I already know why I'm giving you the assignment. Mention the 3 forms of heat transfer. Heat transfer by convection in a liquid is due to dash. A, latent heat of evaporation of the liquid. B, increased vibration of molecules of the liquid about their mean position. C, variation of density of the liquid. D, expansion of the liquid as it is heated. The answer, heat transfer by convection in a liquid is due to D, expansion of the liquid as it is heated. Expansion of the liquid as it is heated. Okay, let's look at this question. In a compound microscope, you know, I have different kind of microscope. In a compound microscope, the objective and the eyepiece focal length are dash. Before I even answer this question, remember that if you watch this very video till the end, if you watch from beginning to the end, I'm going to give you free JAMB syllabus and free JAMB past question. For those of you that will watch this video from beginning to the end, you will qualify for free JAMB syllabus, and free past question. And that is for members of our channel. If you have become a member of our YouTube channel, you will receive free JAMB syllabus and free JAMB past question on your 4 subjects: use of English, chemistry, physics, biology, and any other one, mathematics, any other one, just for your 4 subjects. In a compound microscope, the objective and the eyepiece focal lengths are dash: A, at infinity; B, long; C, short; D, the same. In a compound microscope, the objective and the eyepiece focal lengths are C. The answer is C. They are short. They are short. That is why you need to study waves, study microscope, study types of microscope. Note these things I'm saying, write them down and go and read them up in your textbook. Study waves, different types of waves, light wave and other. Study microscope, everything you can about microscope. Then study thermometer and thermometric liquids like acid, like mercury, and all the rest. When a telescope is in normal use, the final image is at dash. This is question 27. When a telescope is in normal use, the final image is at dash: A, infinity; B, the focus; C, the radius of the curvature; D, the near point. When a telescope is in normal use, the final image is always at A, at infinity. Okay, I hope you are noting this. By the way, are the videos I'm making helpful to you? Are you benefiting from this channel, from these videos? Sometimes I feel I'm just wasting my time. If these videos are helpful to you, please tell me in the comment section. Give me a testimony of how the videos are helping you. Also, if there is a certain kind of video I have not done that you want me to do, also let me know. When a negatively charged rod is brought near the cap of a charged gold leaf, JAMB is always asking this question, even WAEC. When a negatively charged rod is brought near the cap of a charged gold leaf electroscope, which has positive charges, the leaf dash. Pay attention. Let me take the question again. When a negatively charged rod is brought near the cap of a charged gold leaf electroscope, which has positive charges. Remember, negatively charged is coming to positive charges. The leaf dash A remains the same. B collapses. C collapses and diverges again. D diverges. The answer is it remains the same? Does the leaf remain the same? Does it collapse? Does it collapse and diverge again? Or does it just diverge? The answer to question 28 is just B. The leaf collapses. The leaf does what? Collapses. Okay, we move on. The maximum power transfer occur in a cell when the internal resistance is dash. The maximum power transfer occurs in a cell when the internal resistance is dash. A, twice the internal resistance of the cell. Okay, the maximum power transfer occurs in a cell when the external resistance is dash. A, twice the internal resistance of the cell. B, the same as the internal resistance of the cell. C, greater than the internal resistance of the cell. And D, less than the internal resistance of the cell. The maximum power transfer occurs in a cell when the external resistance is dash. A, twice the internal resistance of the cell. B, the same as the internal resistance of the cell. C, greater than the internal resistance of the cell. And D, less than the internal resistance of the cell. The answer is B. The answer is B. The maximum power transfer occurs in a cell when the external resistance is the same as the internal resistance. The same. Okay? We move on. PHCN. Who can tell us? You, please go to the comment section and tell us the full meaning of PHCN. If you're a Nigerian watching this, or if you're a Nigerian, whether you are within Nigeria or outside Nigeria, you should be able to know this. Okay, PHCN measures its electrical energy in dash. A, watts. B, kilowatts per hour. C, watts hour. D, joules. Which measure does PHCN use in their measurement? It is B, kWh, kilowatts per hour. What is the best method of demagnetizing a steel bar magnet? What is the best method of demagnetizing a bar magnet if it's already magnetized? What is the best method of removing the magnetic property from the bar magnet? A, hammering. B, heating it. C, rough handling it. D, solenoid method. What is the best method of demagnetizing a steel bar magnet? Is it hammering it, or is it heating it, or is it rough handling it, or is it solenoid method? I want you to know, just note it. The answer is D, solenoid. You just use solenoid on it. The magnetic properties will begin to reduce until they all finish. Question 35. This one doesn't require calculation, but you just need to know it. The magnitude of the angle of dip at the equator is dash. You know, the equator is more like the center of the earth. The magnitude of the angle of dip at the equator is dash. A, 360 degrees. B, 0 degrees. C, 90 degrees. D, 180 degrees. The magnitude of the angle of dip at the equator is dash. A, 360 degrees. B, 0 degrees. C, 90 degrees. And D, 180 degrees. The answer is simple. The answer to question 35 is B. At the equator, the magnitude of the angle of dip is 0. Just note this. This one you don't need to calculate or press calculator. Just note that the answer is 0 at the equator. At the equator. We move on quickly. When an atom undergoes a beta decay, the atomic number of the nucleus dash. This one has to do with fission and fission. Okay? Atomic decays. Okay? When an atom, remember to read this up. Okay? When an atom undergoes a beta decay, the atomic number of the nucleus dash A remains unchanged. B, decreases by 1. C, increases by 1. D, becomes 0. Just note the answer. When an atom undergoes a beta decay, the atomic number of the nucleus, the answer of 36 is C, increases by 1. The atomic number will increase by 1. We do what? Increase by 1. Which gas produces a pink color light in a discharge tube? They are fond of asking this question. I think I've treated it in part 10. Which gas produces a pink colored light in a discharge tube? Is it mercury, argon, air, neon? The answer is in a discharge tube, the gas that will produce a pink color is air. Air. Which gas produces a pink colored light in a discharge tube? The answer is simple. Air. Air. Okay? In a common emitter configuration, remember that we have done a lot of videos. What you are watching is part 14. If you need me to give you access to all the videos we've done on physics, starting from part 1, part 2, and all the rest, you can get all of them so that you sit down from part 1 to watch. Do you want me to give it to you? Tell me in the comments. But that is for members of our channel. You have to be a member first. In a common emitter configuration, also we have done videos on chemistry, physics, biology, economics, use of English. If you want me to give you the link to all of the videos we've done on those subjects, you are free to also ask me if you're a member. In a common emitter configuration, the output voltage is through the dash. In a common emitter configuration, the output voltage is through the dash. A, resistor. B, base. C, collector. D, emitter. In an In a common emitter configuration, the output voltage is through the dash. A. Resistor. B. Base. C. Collector. D. Emitter. The answer is emitter, 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 emitter. Okay. Question number 41. Look at this question. What type of reaction is represented by the equation? Can you look at the equation? Look at this equation very well. Is it ionization? Is it fusion? Is it fission or chain? Is it ionization? Is it ionization or fusion or fission or chain? The answer is B. The answer to question 41 is B. What is going on here is a fusion reaction. A fusion reaction. By the way, I want you to come under the comment of this with the assignment number 3. Tell me the difference between fusion and fission. Fusion, B and C. Tell me the difference between fusion and fission. Also, to receive all these materials that I have promised and to be a member, you do 4 things. Number 1 is join our YouTube channel. When you join our YouTube channel, you become a member of Noble Tutorials YouTube channel. If you have not become a member, and you need to be a member so that you can receive those materials. And when you become a member, you can be able to ask me your questions directly. You can be able to chat with me on WhatsApp and tell me your problems, and we'll be able to start working on it together with you. Number 2, when you join, go ahead and join now. After you join, come back and like this video. Click on like this video. Number 3 is for you to share this video. Share this video here on WhatsApp, on YouTube. Share it, copy the link, share the link on WhatsApp groups, to your WhatsApp friends. Share it on Facebook groups, share it on Facebook status, share it on WhatsApp status. Share this video on Telegram channel. Share it everywhere. Your classroom, your classmates group. Share it to all your friends. Then finally subscribe to our YouTube channel. When you subscribe to our YouTube channel, come under this video and type I have subscribed. Remember, join, like, share and subscribe. Once you subscribe to our YouTube channel, come under this video and tell me I have subscribed. I have subscribed. Once I see you type I have subscribed, I will chat you up and send to you all the material. That's if you already joined. Remember, there is a very important video I'm leaving for you on the screen. Click on it immediately and watch.